Hey guys, welcome back to the channel everyone. Today I'm going to discuss about the Amazon interview questions for the role of SDE-I, and I'm going to discuss one of the questions asked in one of the rounds of the interview process. So let's get started with this video. So the question I'm going to discuss here is I would say a medium level problem. So let me first describe what the problem asked was, and then we'll move on to the solution. So what we are given as input is a numeric string. For example, let me say 1 1 1. Say this is the input string given to us, and there is a mapping. We know that for the alphabets A to Z, like A corresponds to 1, B corresponds to 2, and so on. So the task we are given is we have to find out the number of decodings for the given input string. For this, for example, if I consider 1 1 1, then what can I say? I can say like it can be A and another A. So 3 times A, that is one possibility. Other is I can take these two and then write as K. I think 11th character is K and then A. Similarly, I can just take these two and one, so A K. So if I add, this is going to be total of 3. So we have got 3 possibilities. The one more thing to keep in mind is it was given in the question that no zeros will be there present in the string and string is not empty. These two conditions were given beforehand. So that was the assumption given. And one more thing we need to keep in mind while solving is while decoding, considering two characters I can say at a time, then what happens is the numerical value of this should be less than 27, because we have characters from 1 to 26 only, so there is no point in considering the numbers greater than that. So that is one point we have to keep in mind. So first approach we think of is a recursive approach, I can think. Okay, so let me tell you about it. So let me take this example only, 1 1 1. Okay, so now say this is the string we are given. So for this we have two possibilities. We will start traversing from the end. So we have two options. One is if I consider one character at a time, then what is left with us? 1 1. If I consider this one. Now second option is I consider both these together. So what am I left with? I am just left with 1. Correct? So let's just wait a second. Yeah. So again here also we have two choices. If I take individually, I am left with 1. If I take both of them, I am left with a string of length 0. Let me represent empty string by writing E. Okay, E is equal to empty, just for the representation purpose. Okay, and 1 is always going to give me an answer. Similarly, 1 is always going to give me an answer. So if I count all these, well, I need not write this as empty. You can just simply, for 1 we always have the answer. So 1 2 and 3, so total 3 possibilities, as I had told above, like this one. Okay, so this is one of the sample cases. Now if you would like, I can just show you. Let me show you one more example with a different one. Let me take 1 2 3 4. From here, using the similar approach, what we can do is we can simply have two things like 1 2 3, and you might be thinking like we can have this 3 4, two characters, but hang on, we can't have this. Why? Because this is more than 26. We don't have 34 letters in the alphabet, so this choice is not taken. So we'll just take this route. So now again this is another sub problem. So what we do is we have two choices here, 1 2. You'll always take this one branch, that is always taken, but this one will be taken or not depends on what the numerical value of the last two characters is. Here it is 23. This is under the limit, so we will take this. So we are left with just 1, right? Now for 1 2 we will have the choices like, if I take just 1, I will have 1. If I take both of them, I will be left with empty string. So what are the choices we have? 1 2 3, right? We have got 3 choices for this. So this is the answer for this one is also 3. you can even check this out, like 1 2 3 4. What can be the possibilities here? One can be A, B, C, D, right? This is one possibility, and other possibility is going to be your 12 together, 3 4, another one, like 1 2. What is 1 2? I think it's J is 10, K is 11, L is 12, L and 3 4. 3 is what? C, D, L, C, D, right? And other possibilities we can have is like 1 separately. We cannot have 34. We can have 23 and 1 4. So 1 is A, 23 is what? I think 26 is Z, 25 is Y, 24 is X, and this is going to be V, and this is what? 4 is D. So these are the three possibilities. We do not have any further possibility. So this is going to be all, right? So now for this approach, let me go with the code to show for this one. This is the code for this. So what we are doing here, I have written this in Java. You can go with any other language of your choice. The algorithm is going to be similar, just the syntax is going to be different. So let's start with the code. So what we are doing here, we are just taking the input string, we are finding out, and we have built a function count that will return the possible decodings, and just which takes in the parameter of that string and its length. So our base case, as I have told you earlier, whenever we reach the end of the string, like the empty string, or we have just one character, a decoding is always possible. So that is why we are returning 1, and anything less than 0 doesn't make sense, so that is 0. So the one choice we always have, so we are always going to take this function call for n-1 for one character at a time. That choice is always available, but for taking 2 characters, we first need to check if that 2 characters numeric value is less than 27. For that, what we are doing, we are taking and checking if that 10th digit is 1 or 2. Only these 2 possibilities are allowed, because if it's 3, it's more than 30. That doesn't make sense. And also the ones place should be less than 7. If that is the case, we are also making another recursive call for n-2, and in this way the whole calculation is done, and finally the result is returned by the variable C and to the calling function in main, and that is printed out. Fine. Now, is this the most efficient method? That is debatable. Why? Because let me take another example to show you why. Let me take this is another example. Say this is the string I have been given, right? This is the string I was given in the interview also, to do the dry running. So what we do is, we have 2 choices, as I have explained, 1 2 3, and here only if I take 2 of them, I will be left with this. Another choice here, if I take only 1 here, if I take 2, I am left here. Another one, if I take only this, and here I have got an empty string. This is only 1 empty string. This is 1. Okay. Now the total possibilities is 1 2 3 4 5. 5 possibilities for us. But the important thing to note is, look at this one and this one. Aren't these two the same thing? We are just calculating twice unnecessarily when we have firstly calculated this. Why we need to compute this again? This is an overhead. So imagine this is just a 4-length string, and imagine if I had taken a much larger string, then just imagine how many sub problems we would have been overlapping, and we would need to solve them again and again unnecessarily. So what we do is, we use the concept of dynamic programming here. We only solve these sub problems once, store the result in a array, and before calculating this again, we first check in the array. If the result for that is already calculated, then we need not calculate it again. So what we do is, we just check from the array if we have calculated it, and if it's there, we just simply return that. Okay. So that is something we are just going to do. Let me show you the code for this here. Yeah, so first we create a array. Okay, as usual we take in an input string and calculate its length, and initially we fill all the values for the array as -1 just for our ease to check if that value exists or not, that is we have calculated it before or not. That is something we have to check. Now we come to the function. The base conditions are same as before, only changes before going for further calling we simply check if we have already calculated that before or not. If yes, if we have already calculated it before, then there is no point in calculating it again, so we simply return that value. Else we are just going to go with the previous logic and store that there, and also do this, everything is same, just we store the result. And what this does is this reduces our time complexity from exponential to linear time. Now that is a drastic change and significant. So the time complexity for this is going to be order of n, as well as we are using extra space in the form of an array, so the space complexity is also going to be order of n. So this is how this problem can be solved. It is a medium level problem, I would say, and this is the first question I was asked in the interview. If you like the video, please do subscribe to the channel and let me know in the comments if you have any doubt, and also let me know if you want me to make some more videos on these interview questions. I have got much more. If I get a good response on this video, I will make further videos. Till then, thank you for watching the video. Goodbye.